Hello YouTube, welcome to my video. I previously showed you how to derive the equation velocity and acceleration in spherical coordinate. Today, I will show you how we are going to use them. For this question, we have a satellite with mass m that's moving under the influence of the gravitational force and frictional force. The and we are given this equation as as, as the force equation. For the r here is the distance to the center of the earth with alpha, yeah, g, and the big M, which the big M, which the capital M, is the mass of the earth, and gamma, the equation gamma is larger than 0. Okay, so now we are going to use the result from the previous work, which is velocity and acceleration in spherical coordinate. Mm. We're going to determine gamma, beta, and eta in this, and so that this ansatz is the solution, solves the equation of the motion. What is the shape of the trajectory, and find um, find the speed, which absolute v as the function of r. So remember that we are given this equation. The task here is to find speed, which is absolute v, and these are the ansatz that's given. Okay, remember that F equals to ma, which this a is the acceleration. So we are taking from the remember that in where's the cursor? Okay. Okay, and we have this, which we calculate in the previous video, and also this. As we substitute this into the equation, we'll end up with so what we gonna do from here? Well, we'll calculate the differential for the ansatz, this thing here. Let's make it quick. I already calculated this in advance, and the result are this. Oops. And because this is constant, so the differential equals to 0, and we can eliminate these terms. This entire thing basically. So now we are left with these two, and from this you can basically find the equation for gamma pretty easily. Well, let me scroll down a bit so we have more space. Rewriting it, we have this. And we just divide by this, so what we get is I'm skipping some steps here, but I think it's pretty obvious how to do it. And then we substitute from this. So what we get here is and what about the beta? Oh, we will substitute this to the first one, this one, and we'll get the beta. We'll substitute. The reason I keep R is because we'll Because of this, it will be easier if we keep the R. You see? Okay, this is a bit too long. So let's continue here. Okay. So what we get is square I think from here you can tell that and therefore okay, so we get the gamma and the beta here. What's next? What about the eta? Well, because f dissipation will only make sense for, and therefore remember what is this f dissipation? Is this part? Is this part? So it only makes sense if it is positive, and therefore gamma is positive, and for and because gamma is positive, beta and eta are automatically positive. And from here we can infer that the trajectory is a logarithmic spiral, which following the equation of and therefore v square equals to which is in line with is in line with the with which the typical solution for free fall. So yeah, so this is the solution. Thank you for watching. For the next video we'll talk about raindrops. Well, it might interest you a little bit better. See you next time. Ciao.